There, now that's nice. Right.
Beautiful.
All right, I'm gonna see you join it. Awesome. So where we left it last time is, if we go, I think we have a nice checklist up here somewhere. Yes, so basically last time we spent implementing this feature here of supporting interruption. And so the payoff of that was if we go down to our little example here, let's see, is this, yes, so this is going to start, then it's going to print these dots forever, and then we're going to wait 3 seconds here, and then we're going to interrupt this fiber. And let's try first go to the right project. ZIO From Scratch. Okay, so I'm going to try to run this. Let's see if this works. We got lots of dots. Hopefully, I'm sure this will stop works. I thought we'd implement that, or maybe we need to. Oh, or maybe we were. Did we implement this, or was this the last thing we needed to implement?
Let's see. Let's see. Yeah, I think we got interruption to work. At least at some point, maybe we added some more that broke it. Which one are we running? Interruption example.
Now, did we do the yield? Let's see. Did the yield op count?
Yeah, and this one is.
Let's make sure we're running the right thing here.
This one is yielding, right? I believe we had some odd behavior with debugging in particular.
Let's try that one more time.
Well, this one's doing read line. No, we're not even calling read line. That's not even being used. Fun.
Let me try this one more time.
Okay.
Yeah, I thought we had this working the last time, but.
Maybe I could have, yeah, is it still going? Is it just adding more messages? Yeah, it looks like it.
All right, maybe we need to investigate this here.
Okay.
Interesting.
Interrupt.
All right. So maybe let's go back to what we did have working, and then we can. So I think what we definitely had working was something like. Let's see.
Like a sleep, right? I think we were able to get a sleep done.
Yeah, let's try. Yeah, so let's try. I think, do we implement sleep?
Actually, perhaps not.
I think we had a simple one, but yeah, let's just do that. Let's just do this. Yeah, so let's make sure we have this working, and then we'll go back to this. So we want to do that, and then we had our little sleep delay, and then we interrupt the fiber.
Cool.
It's right here. So I think if we do that one,
cool.
Let's make sure this at least works. Oops, small project. Oh, yield. Okay. So we interrupted this and we got the exit value. So that works great. And then I think what we were doing at the end of last time, I think maybe we thought we had working, but let's see what we were doing is we were talking about this concept that the way interruption works with this ZIO 2.0 actor-based fiber runtime is that interruption occurs through sending this fiber message interrupt here in particular. And then the fiber, when it processes that message, it handles that interruption. But what that means is that if the fiber never processes more messages from the inbox, then it's never going to get that interrupt message, and behavior in like this one is not going to work, because essentially this fiber is just in a while loop forever, just printing out these dots, and it never takes a break to get more content from the inbox. So what we implemented last time that maybe we needed to work on here is we added this concept of this yield op count. So I guess right now we said it was 300. And then we said, as we're going through this run loop here, every time we do an operation, we're going to increment that yield op count. And then when we get to, we're going to increment that op count, and when we get to the yield op count, we're going to stop looping, and we're going to essentially yield back to the runtime. So we're going to offer to the inbox a message to resume ourselves, which then is going to cause this run loop to stop and is going to cause us to go back to the inbox here and process these messages. Now, one thing I am thinking about here is I think we've got a little bit of a race condition in resumption here, potentially. Let's kind of think about this. So we basically have these two messages that want to resume and then want to interrupt. And so I think this is something, and this may be the cause of our problems, of essentially we want to make sure we're doing the right thing if interruption has already occurred and we get a message to resume, right? So it could be that, right, because here this is going to say this is interruption, and then it's going to start the run loop, which may cause the fiber to actually end its life, but then this is going to kind of start it off again, which it really should not be doing. So I think we can address that here.
Basically just check that the result is not null, sort of.
Yeah, I think that's at least a good starting point here. I mean, this is one of the cases where there are some kind of tricky things we want to think about, but I think that's kind of a good starting point for us here. So basically, if we're asking to resume, yeah, and I think essentially there's really, yeah.
To resume a fighter that is done Copilot. Okay.
So let's now go back to our example here. And so now we want the interruption one.
All right.
Okay, so we are, I don't know what the null is.
So that's the result. Attempted to resume a fiber that is done, and then it printed out null. That's interesting. Attempted to resume a fiber. So we're saying result is not equal to null. Do this. Oh, I think we want to say if it is null, we want to do this. And if it's not null, then we say.
Oh.
I think we got it backwards.
Yes. There we go. All right. And so let's remove our little debugging statements.
Oh, that's interesting. So attempted to resume a fiber that is done, failure, interrupt. Interesting. I wonder why it attempted to resume with the interrupt. Maybe if this is because of a join. That's odd.
No. I think this is expected because. Okay. So here, let's kind of go back to what's going on here and think about this. So this one is going forever, right? It's just printing a dot, and after it prints 300 dots, it asks the fiber to resume itself and print more dots. So it's printing the dots, then it gets to 300, it yields. Then we send the interrupt signal. Then this one, because it asked it to resume itself, and now that's exactly where this is getting printed, and that's what we would expect here of the result is not null, the result is interrupted because that's what happened when we interrupted it. And now we're good. So
yeah,
I
thought for a moment that was the ZIO, but then that's the result. Yeah. So we finished with the interruption earlier. And so I guess exactly what you thought was happening before was happening where we were resuming here. So cool.
Yeah. So let me just comment this out maybe, and our little op count. Do you already get it?
Not the op count one, but I'll look for it. Yield count, I think, right? Or no, op counts.
Oh, here we go. There we go. Okay, so now let's just try running that again. So we get lots of dots, and then we exit with a success. So great. So all right. So slight detour from our recap of last time, but actually a good one. And I mean, I think it kind of reflects a good point that there is a lot of complexity here. And I mean, I think we're kind of trying to give you the kind of key points from it, but there are a lot of subtleties here that probably are not even going to kind of fit into a symposium. And maybe as we go, we'll try to kind of highlight a couple of those, and depending on time, maybe an interest, we can kind of dig in on a couple of them. But okay, so
actually, from Juan Manuel, which is so the run loop and fiber. Sorry, so the run loop and process fiber message work as coroutines. I will let you respond to that, Adam, if you have a knowledge of coroutines, and if that is indeed correct. Are they working as coroutines?
I think that's fair, that we bounce back and forth between them. So we run the run loop for a while, then we take a break and we hand it over to processing fiber messages, which may be something else, maybe wanting to interrupt us or add an observer, but maybe then coming back to the run loop. And so, yeah, we kind of go back and forth between those two to maintain that fairness property, that we want to be efficient in just executing the work of this fiber, but we also have to be responsive to messages that the outside world sends to us.
Great.
All right. So this is great, but among other things, one of the limitations of this right now is that we don't have the ability to add any concept of finalizers. And so here we're just printing dots, so it's not the most exciting thing, but we could imagine maybe this is opening a file and then processing all the lines of the file, and it's got millions of lines. So we're like incrementally processing all these lines. It's taking a long time. And so it's great that we can interrupt this because maybe we don't need the stuff in the file anymore. But we need to say that when we're done, we want to make sure that the file gets closed. And we don't really have the ability to do that right now. And it's kind of something that you really don't have in stuff outside of ZIO or effective systems like it, where if you're using a resource, the way you would normally do it is you would do try finally. And in ZIO, you can do the same thing in terms of just synchronous code by using one of those like catch-alls operators. But try finally or catch-all isn't going to deal with this possibility of interruption here. So what we're going to want to do is have the concept of being able to mark some regions as being interruptible or uninterruptible. And then we're going to want to build more logic and semantics on top of that, so that we can say that that finalizer has to run uninterruptibly, or maybe these dots are really important and we're only going to do this 300 times or 1,000 or whatever, but we need to make sure there can be no interruption of the dot printing. So to do that, just like before, we're going to have almost like a first part that is kind of data modeling, of we've just got to have like the kind of the data and the structures to represent that information and to communicate it. And then we're going to have a second part that's kind of semantics of like, how do we want this to fit into the run loop, and like when do we want to do different things with this. So the first part, the most basic level, is we're going to need this fiber to have some concept of whether it's interruptible or not, so that when it gets one of these interruption messages, it knows, is it interruptible or not. So in ZIO 1, this was just kind of basically like a Boolean. In ZIO 1, we didn't have this inbox concept, so it was more of like an atomic Boolean. But in ZIO 2, we've tried to make this a little bit more systematic. And so we have this concept of what we call runtime flags. Maybe let me go down here. And so it's got a more compact representation in ZIO itself, where it's basically just this like bit set, and each bit like corresponds to one particular flag. I think that's probably a little bit more than we need in the Zymposium. That maybe could be its own little thing of like, how do you do like bite back representations of things? But I think for us, maybe we'll just make it a set of runtime flags. Yeah, and exactly, it's doing exactly the right next thing of we actually need some concept of runtime flag. And right now, I think only really need one runtime flag, which is this one for whether we're interruptible or not.
Mm-hmm. Great.
And then if we wanted to, maybe we could have companion objects, and maybe we'll call this like default. Oops, default. And default is that we are interruptible.
Nice.
And so now that we've got these runtime flags, the first thing we're just going to need is when we create one of these, we're going to need some runtime flags in here. And a easy way to do this initially is going to be to just have these runtime flags here.
Mm-hmm.
I'm actually going to make this a var. Now note that this isn't probably in the ideal world ultimately what we want, because one of the properties we're eventually going to want is for these runtime flags to be inherited from the parent. So, right, like if you are a fiber and you are uninterruptible and you fork a child, that child should also be uninterruptible. And so probably what we ultimately want to have is actually when you create one of these fibers, you create some runtime flags and you put them in there. And maybe we'll kind of add that in a minute, but let's just start kind of adding some machinery, and we'll build that in potentially. And then I think the other thing that probably would be good here is let's just give ourselves a helper method that just is interruptible.
Now I'll add a helper method on the runtime flags of the same name.
Okay. And it looks like if we're going to it's done that. Okay, great. All right. So now we've got a way to know whether we just go to fiber runtime. Okay. So now we've got this little helper method here to tell us whether we are interruptible or not. And so now we could start to say, okay, what is our logic if we're processing these fiber messages and we get an interrupt signal? What do we do? So I think that maybe the easy part is if we are interruptible, then this is basically our existing logic. What's our logic for if we're not interruptible?
I would guess to not interrupt.
That is definitely true. But one of the things we're going to have to think about is so yeah, let's actually kind of think through this. So don't interrupt ourselves right now. But let's say we're in this uninterruptible region, and then we exit the uninterruptible region. So then we need to immediately interrupt ourselves. So we need to
Interesting, yeah.
So we need to keep track of some additional information to remember that we have been interrupted. So that's one thing we need. What's that?
I was just going to say, sounds like a job for another variable.
Yeah, exactly. So let's, we could do that now. So let me add another thing here. So why don't I call this private var interrupted cause. And this is going to start off just being, do we have cause.empty yet? Or maybe, oh, we probably haven't because we haven't done the fancy version of cause. Okay, so in that case, maybe I will follow Copilot's suggestion here. So in the real version of ZIO, you can have actually an empty cause, and we have these both in these and cases. So you can combine different failures together because you might have like two workflows you run in parallel and they both fail. So you want some way to capture all of those failures. But I think that's another thing that is probably easy to defer on for now because we've got enough other stuff figuring out. So we'll just use an option here. And so then let me add another little helper here. So we'll say def is interrupted, Boolean is equal to interrupted cause is defined. So now then in this implementation here, we could just say, and actually I think in fact either cause, we'll come back to this in one sec. So yeah, I think we can actually extract this logic probably to the beginning of this thing. Oops, that's the not the one. Okay, so now in either case, we're remembering this information that we have been interrupted. And then if we're interruptible, we'll process this right now. Otherwise, we don't need to do anything. Does that make sense?
Mm-hmm. Yeah, for sure. I wonder, is there maybe going to be a way to simplify this bit once we handle the else case? I'm not sure exactly. We'll see what happens. But I'd imagine if we're checking the interrupted cause inside the run loop, we could probably just eventually call run loop here, but I'm not sure. So we'll see.
Yep. And one other thing here is really what we want to do here is we could get interrupted by multiple people. So we don't necessarily want to overwrite the interrupted cause. What we really want to do is we want to take the new interrupted cause and we want to combine it with the existing interrupted cause. But that would require us to have a way of combining the causes, which we don't have. So we will punt on that for now.
And I think similarly, the real ZIO cause it tracks the fiber ID of who the murderer was, essentially. So
correct.
I guess I need that. Cool.
Okay, so we've got kind of some ability to remember the fact that we've been interrupted here. Now, the other thing we don't have right now is we have this concept of these runtime flags, but we don't actually have any way to change them. So we don't have any way to make ourselves interruptible or uninterruptible. So let's work on that. And so we're going to follow basically the same pattern that we have before, where we had our object ZIO, and we had these different terms of our language. So we had succeed, we had flat map, async, fail, fold. I think those was all of them right now. And so we're going to add a new term to our language. And right now, I'm just going to make this a function from runtime flags to runtime flags. This is basically like kind of how we want to like patch or update the runtime flags. In the actual ZIO, we have the patch is actually its own data type. And so you can kind of represent them and compose them and you can like reverse them and do things with them. And maybe that's another like cool Zymposium we could do. But right now, to avoid kind of implementing that whole logic, we're just going to have this be a function. And this is going to extend ZIO nothing unit. So now that I've got that, I can then use that to implement a couple of operators. So let me start by just implementing a update runtime flags. No, not quite, but good try.
Cool.
Okay. And so let's think about what we could do with this. And this isn't going to quite give us all the power we need, but we'll kind of take one step at a time here. So let's think now about, I'll go down here and I'll, so, oh, and actually I'm gonna maybe add a couple of other operators here. So maybe I'm going to implement one right now that I'll call set interruptible. And this will just be a ZIO nothing units. And something like that, because we have, so we have these runtime flags. So we can do, we can either add a helper method here, or we can just copy.
You could do plus, and then I'll add it to. I'll add those methods. I'll add a plus and minus.
Okay. All right. Perfect.
Cool. Hopefully that works. No, not quite. Interruptible is not. Is it? I think is interruptible? Oh no, it's just interruptible. Did I miss?
Oh, but it's runtime flag, not flags.
Yes.
And
then
now I'm. Oh, I think I misspelled it down here.
interrupt or someone. It looks the same. Interruptible. Oh, interruptible. Oops.
Yeah.
Interruptible. No. I'll fix that.
Okay, cool. All right. So now we've got a way to make this interruptible or uninterruptible.
Mm-hmm.
And so let's like start to create some like simple examples here, and we'll see there's kind of some stuff still missing from this, but so let's say I'm going to create a child. So this is, I'll end up forking this. And so I'm going to set this as uninterruptible. Then I'm going to, how do I do my little dots? I'm going to debug the dot. Do we have a way that we have re-implement repeat yet? No. So let me, maybe we will do that shortly. And then this interruptible. And then maybe I'll do stars. And I'll do that. Forever say. And I think Kid is already working on implementing it.
Yep. I think I've got that. Cool. Oh, did I? Yeah, I think it's fixed now.
Okay, and then let's just make sure we've got kind of some reasonable timing here. So maybe here, I'll do okay, so let's think a little bit about our expected semantics and what we need to do to actually start to implement this. So we're setting this to be uninterruptible, which we saw above our logic is we're not actually going to stop something from happening. We're just going to set that interrupted cause. Then we're going to do this speak with delay. Then we're going to, and we're going to wait 2 seconds for this. And so we're essentially going to make sure that by the time we're running these dots, we've already gotten interrupted here. And our expectation is we're going to see all these dots. Then we're going to restore our interruptibility. And at that point, we're going to start doing these. And our expectation would be that ideally none of these are going to be printed, or at least a very small number of these are going to be printed, and we're going to terminate the program at that point.
Cool.
So right now, this is not going to work because once we set this, once we restore interruptibility, well, so actually 2 reasons. One, we have not implemented the interpretation of these update runtime flags at all. So we need to do that. But 2, we don't have any logic to say once we restore our interruptibility that we're actually going to check if that interrupted cause has a value and do something with it. So let's work on those 2 things. So the first one, we'll go back to our interpreter here. And so we'll just add a new case here. Case ZIO update runtime flags. Maybe we'll call this the patch. And so here we could say val updated runtime flags is equal to apply the patch to the runtime flags.
Mm-hmm.
Then a little bit of an optimization that we could do, but we could say if the updated runtime flags are just equal to the current runtime flags, then we're just going to return the unit value. We don't have to do anything because there was no change. If they weren't the same, then we need to set the runtime flags. Right now, we're just returning ZIO.unit. Here's where we have this like little bit of extra work that we have to do. We could say if, so once we've set the runtime flags, then we could say if is interrupted, and is interruptible, then when you do something, otherwise we do something else.
Nice.
And so if we're not in this like particular situation where like now we are interruptible, then we can just return the unit value here. Here, I think we could say, and again, we're kind of there is a lot of complexity here, so we're kind of trying to get the basics here. But we could say our current ZIO is equal to ZIO.fail cause interrupted cause.get. And we know it's safe to call get here because is interrupted was basically saying, is it defined? And we know we're in a single threaded environment here. So it's safe to do those two things separately. And did we just not have ZIO.unit?
We don't.
Possible.
we do not yet.
All right, so let's follow Kit. We can see the very exciting implementation of ZIO.unit.
Oh boy, let's do it. Here's succeed. Let's do it right under interrupt. Val unit. Gather around, everyone. Nothing. If I can type, there we go. Nothing to see here.
Okay, so now I think we should have the basic machinery for doing this here. So let me actually, so I don't want to run this. Let us say about exit equals initial regions. Let's see if this will work. So we're waiting. And there we go. So we did manage to successfully interrupt this. Let's just try. Yeah.
It looks like, if I'm not correct, because it printed out attempted to interrupt child. Oh, so it looks like it started doing, it became interruptible before we attempted to interrupt it. I would have thought that maybe we would have seen some dots, right? Because we're waiting 2 seconds before
We're saying all the dots.
Oh, sure, but I just saw that. I noticed that it's. Oh, wait a sec. Does interrupt wait for the fiber to be interrupted before continuing? I think we do have that semantic here, or no?
Yes.
Okay.
Yes. This is really This is really done interrupting
yes.
child, and here we should say something like debug.
Yeah. Gotcha.
About my child.
Yeah, I forgot because we interrupt fork, which was going to do it. So yeah, the default behavior in ZIO is to also wait for it to be fully interrupted. Okay, great.
Yeah, and so we see at the very beginning about to interrupt, we get our dots, we get some of these, and then we are done here. So that's like, starting to go in the direction that we want to go. Now, what we're going to want to do, exactly. Let me just check if anyone has any questions on this so far.
He's typing, I believe.
Okay, excellent.
But I'll keep an eye there. But so far, so good.
I now have a fancy second screen to. Okay. All right. Perfect. All right. So I think the next step here is if you look at these things, these are actually not really operators that we have in ZIO itself, because what we really want to do is we want to be able to just say like a certain block should be interruptible or uninterruptible and not have to worry about kind of manually setting it and unsetting it ourselves. So let's, so let me actually maybe go back to that stack, and let's just show that. So let me increase this. So I think there was a question about why, so previously when we have this at 100, and I think is actually kind of a good thing to illustrate what we were talking about, these like yielding semantics. So if I have this set to 100 here, then when we restore our interruptibility, we're still in the run loop. So we haven't checked the inbox yet. And so we basically print roughly, I mean, it's less than 100 stars because there's multiple ZIO operations in printing each of the stars. But we basically do another 200 operations of star printing. Then we go back to the run loop, and then we get the interrupted signal, and then we process it. So that's actually the case, even though we kind of sent the interruption signal immediately. This case here is where the interruption signal is received after we're through this, when we're back into an interruptible region. So that's kind of the easy case. The a little bit of a test for the hard case is this case where I bump this up to like 1,000. Because what this means is that I've yielded a couple of times within just the dot printing. And so while I'm printing dots and I'm in this interruptible region, I get the interrupt signal. I don't stop myself because I'm in an interruptible region, but I set that interrupted cause. And then as soon as we exit the interruptible region, we stop. And so you'll see in this case, we don't see any star printing, because now as soon as this interruptible gets executed, we check for interruption. We've already received the interruption and we immediately stop. Does that make sense to everyone?
Makes sense to me, but yeah, definitely details here. Yeah.
Definitely details here.
And one of the reasons for these yield op counts is for performance, in case anyone is wondering, right? Like we do not have the ability to be interrupted the second someone demands it, but it would be really expensive to continuously sort of jump out of our ZIO processing loop to keep checking our message queue, right? That would kind of be a waste of yeah, it's a bit of a trade-off between being interrupted at the drop of a hat and yeah, spending all that time continuously anxiously checking to see if anyone's interrupted you every operation.
Yeah, and I think the key things to remember there are a lot of times where interruption is most important is when you're doing something asynchronous. And right, like you're waiting for an asynchronous callback. In that case, the run loop isn't even running. So then it can be processed immediately. But I think you're right that if you're kind of just running, one of the assumptions that ZIO, as well as these other functional effect systems have, is that these individual effects are going to be small. And so if we wait for 300 of them or 1,000 of them, it's not a big deal because each of them is just like tiny little building block of like doing a dot or whatever. So if you ever have a problem with this, one thing to think about is like, are your ZIO workflows of the right size? Because of at one extreme, like you can make your entire program be not using ZIO, and then you can do like ZIO.succeed around the whole thing. And okay, you're returning ZIO, you're not really taking advantage of ZIO in that case. At the other extreme, if you're reading bytes and every individual byte you read is like a ZIO, you're probably just inefficient there. So there's a little bit of like figuring out the right size of the effects for what you're trying to do.
And in particular, in a case that people might be imagining, like if you're wrapping blocking code with ZIO, like ZIO.attempt, and you do some long running blocking thing, technically that's just, you know, one ZIO operation. But I believe we have variants that allow for like ZIO blocking interruptible, right? That would, I think, kill.
Yeah, there's an interrupt variant that will actually interrupt the underlying thread for you. Yeah.
So
okay. So I think what we're going to want here is, let's think about making another operator here. And maybe I will make this, maybe I'll start by making it on ZIO, it's on the object. And we can actually have it on both in the actual ZIO. We have it on both. So we have this set interruptible, we have this set uninterruptible. But what we would really like, I think, here is something that is more like interruptible. Yeah, and I think it's going to do a little example for us of what that would look like. Yeah, and so what this essentially does is it gives us the guarantee that anything within these curly braces is going to be uninterruptible. And then if I do something afterwards,
Mhm.
this is going to go back to having whatever the original interrupt status was.
Mhm. Cool. Yeah,
And I think
a scoped operation, even though it's not using scopes yet, or maybe we'll never, but
Yep.
semantically we're scoped.
Yep. And I think this is going to require us to have one more. Well, so let me start with the simplest implementation of this, and then let's see what's wrong with it and kind of what we need here. So a very simple implementation of this. Well, let's start with the very simplest, and then we'll build up. So the very simplest would be,
Hey.
I don't know if we actually even have the right star arrow, but oops, why is that?
I'll rewrite it with the for commands. I think that's clear anyway, probably.
Yeah. That sounds good.
It's terse, but and yeah, oh, I see what you mean for a couple issues possible.
Yeah. But so let's start by taking this, because I mean, this is basically what we had before. So let's just take this and let's use this to kind of clean up our example at the bottom here. So now, instead of using this set interruptible and this set uninterruptible, I can get rid of these. And I could do something like ZIO dot uninterruptible. And then, yeah, I could just put a little. And this should be the same, except now starting to look a little bit more ZIO idiomatic. Let's just do our, and right, that it works the same because it effectively just is the same code, just extracted. So yeah, so a little bit of maybe exercise. So what are some things that are wrong with this implementation here?
Pick me.
Yeah. Or if someone,
No,
well, I don't think anyone's answered yet. So
yeah, no, I'm keeping an eye on the typing, but I'll wait for someone. I won't steal your fun. I can't cheat.
So one thing.
Yeah.
Hold on. So I think there are two things that
we got an answer from one.
Yeah. So,
maybe
so
we're
you're
all
just kind of getting one. Well, and I think even before that, there's a more basic one. So what happens if this fails?
Oh no! Yeah, we'll short circuit, right? And we'll never.
Right. So if this fails, we'll never actually do this thing. So we definitely don't want that. So a first step could be we could rewrite it to something. We could say like. Select uninterruptible. Maybe I'll just be very. And then we could do like ZIO dot. We have this catch-all cause, or actually we'll use fold class maybe. And if we wanted to, we could do something like ensuring if we had that. But right now, I'll just start with this. So this is going to let us do something in either case. And so if we fail with a cause, we'll set interruptible, and then we'll refail with that. And if we have a value, okay, so let's just make sure this files. If it does not quite yet, let's see. Oh, listings lambda.
There we go.
Okay. And so now this will guarantee that even if this thing fails, that we still restore the interruptibility. And maybe let me do the other thing, and then let's see where we are on time. We can come back to this. So, okay. So the second thing that I think Juan correctly pointed out is this is kind of implicitly assuming that we're starting off being interruptible. And so we're saying, okay, well, I got to switch to being uninterruptible, and then I got to switch back to being interruptible. But that's not necessarily true because we could already be uninterruptible. And in that case, this first thing is maybe inefficient, but is harmless, right? Because we already had the logic that, I mean, if we're kind of taking something, we're just sending the same thing, it's fine. It's not a big deal. And we even have that optimization in the run loop where we don't even bother like updating the flags or doing anything if they haven't changed. So that's not the end of the world. But this is kind of bad here because if we were already uninterruptible, then now we've inadvertently set ourselves to being interruptible, which we definitely don't want. So one very easy way we could fix this is essentially what I would like to do is I would like to have something that like checks whether I am interruptible. And if I'm already uninterruptible, I can just ignore this whole thing. This whole thing is just a no-op because I'm already uninterruptible. But if I'm interruptible, then I can do this whole thing and it's safe for me to do it. But that requires me to have some method that we could say like, maybe we call this like get interrupt status, say. And maybe we have some new like interrupt stat, or maybe, right, we'd either have that, or maybe we just call this get.
We have is interruptible.
Yeah, I think that's maybe a simple way to do this without creating additional data types. So this one, we don't really have a way to implement right now because that update runtime flags gives us the ability to set them, but it doesn't give us an ability to kind of get the new ones. So we could have like a fancier version of the set runtime flags, like modify runtime flags and also return something. But I think a really simple way to do it is let's just give ourselves one more thing in our little algebra here. Actually, I might just maybe I'll call this with runtime flags. And so this will be, I guess we haven't implemented the environment yet, but it'll be a little bit like what we'll eventually do with the environment, where this gives you access to the runtime flags and it lets you construct some ZIO workflow based on that.
Very cool.
And so then I can implement another constructor here. I could say maybe we'll call this with runtime flags.
Lovely. And I've thrown a potential implementation down there. Maybe there's something fancier, but this seems to
let me go to you.
Oh, I'll probably need to erase that. I'm not sure if it's going to compile. Maybe it will. We need to erase that? No, it's happy.
Yeah, so I think that is that's great. So then we can go back to our so now this implementation could be with runtime flags. And then do we have?
Want to do a when?
I don't know if we have that implemented yet, but if flags, do we have flags is interruptible, or do we need?
We have a dot is interruptible. Yeah.
All right. So if the flags is interruptible, then we're going to do this. Else.
I think just ZIO, right? But I think we're maintaining the type signature.
Yes. Yeah. But now I managed just, I think somehow we. There we go. All right. Excellent.
Is it happy? Yeah.
All right. And let's try running this again. Oops. What did we do? Not implemented. Where? Oh,
that one.
I
guess we don't need
decided that. I guess, yeah. I mean, we could have, used it.
Sure.
Here, but yeah, we don't need it. Okay, so let's try running this again. So yeah, so now this is kind of a safer version of this, you could say. And so now we could start to implement other resource handling operators on top of this, where we could create a uninterruptible block, and then well, the other thing we can do is we can implement uninterruptible mask here. That's kind of the next variation of that. And so what that's going to do is sometimes we want to be able to both set a region as uninterruptible, but then also be able to restore interruptibility within part of that region. So maybe let me look at, how do you feel about time? Shall we keep going here, or shall we break? How are other people feeling? We can do a little more, or we can come back to this for next time.
I think maybe next time is good. If you're okay with that, feel free to go. Yeah, without me, I'm actually.
No. I think that's good. So basically, to give a little preview, maybe for next time, or I don't know, maybe we'll do the RAF next time. We'll come back to this because we don't want to subject people to forever doing the ZIO from scratch. So we're probably, I think, getting towards the tail end of it. But yeah, maybe we could do one or two more doing like the environment and stuff. But basically, we're going to implement this uninterruptible. Hopefully, you can see from here how if we have uninterruptible, we could implement another version that would be interruptible. That would be basically the inverse of this. And then those two things are going to give us the ability to do a simple version of what in ZIO2 is called acquire release, which is going to acquire a resource uninterruptibly, use the resource interruptibly, and then release the resource uninterruptibly, and guarantee that that release is going to be done no matter how that use fails, whether by success or failure or interruption. And we'll be able to use this uninterruptible and interruptible to do a simple version of that. But then we're going to have a little bit of that same point that we were talking about based on what Juan was saying earlier, that we don't actually, or we want to be very careful about using like interruptible ourselves, because that's implicitly assuming that the outer region was interruptible. And so what we're gonna end up doing is have this like fancier version of uninterruptible that in ZIO is called uninterruptible mask, that gives you access to what we call like a restorer that is going to restore the outer interruptibility of the region you're in. And so in a typical case, that'll mean it'll make it interruptible, but it won't make it interruptible if you're in a broader region that is also uninterruptible. So that'll be kind of the final step to kind of have a concept of resource safety here.
Yeah, definitely an advanced thing, but really, really helpful to know and think about. Yeah, I hope this series so far is good at sort of peeling back the layers of ZIO and sort of the more advanced things. I think these semantics around interruptibility and forking, the details there are sort of what can take you from, you know, feeling comfortable with ZIO to feeling like you're unstoppable. Oh no, I'm getting a phone call. It's happening.
All right. Well, awesome. Well, thank you so much, everyone, and we will see you next week.
Take care, everybody. Take care, Adam.